Hi there, my name is Mike Rothen and this is my cs50 final project. It's a development of a virtual radar display. There's plenty of aircraft radar displays on the internet, such as Flight Radar and ADS-B Exchange, but professional air traffic controllers have a different kind of layout. I thought it'd be fun to produce a professional looking display using data freely available on the internet. My objectives then were to produce a professional looking radar display of the Boston area with a slightly retro theme. To do that, I needed to produce a background map consisting of coastline, airspace and airport, and then overlay it with live air traffic data. The main challenges were to obtain the mapping data for the overlays and how to project those, because the data is in all different projections, and then how to interface to a live traffic API. The solutions I found were to obtain the base mapping from MassGIS, obtained airport and airspace data from the OpenAIP, and live traffic from the OpenSky network. I used QGIS to normalize the mapping data, and PyProj, a projection library, to project the data from OpenSky directly onto a raster screen. QGIS is a very powerful geographic information system. It's free and open source software. I used it to pre-process the mapping data from OpenAIP and MassGIS. A projected coordinate system has northings and eastings in meters from a reference point. I could use this to plot points directly onto a 2D surface. The MassGIS coastlines were high definition. I used QGIS to simplify them to something easier for plotting. I downloaded the OpenAIP airspace using the Google Cloud Storage Bucket API. OpenSky provide a very simple Python API. You can request states and get a list of targets. The targets are in a global GPS type format with latitudes and longitudes. I had to transform these into the Boston coordinate reference system. To do that, I used the PyProj library because it has to be done in real time whilst the application is running. One really interesting thing is the way that Python easily manipulates maps and lists of data. A central part of my application is a list of all tracked aircraft, which is called a target table. I implemented the target table as a Python dictionary, which maps the aircraft identifier to all the information about that aircraft. I wanted to have a series of breadcrumbs behind the aircraft, and to do that within the dictionary I embedded two DQ structures. This time lapse shows the table structure and the DQs growing and changing over time. I really learnt a lot from this exercise, and there's some parts that I'd like to improve. I hope to do that in the near future. So here is the orchestrated dance in the skies above Boston.